morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and the neon lights are about to turn on, boys and girls, because we are oh so close to the greatest 2 days of the year. IB Mathematics Standard Level Paper 1 on Tuesday, May 13th, and IB Standard Level Mathematics Paper 2 on Wednesday, May 14th. Okay, this is the solution to exam jam number 7. Ooh, what a coinkydink right there, number 7. Let's get to it, shall we? A company uses two machines A and B to make boxes. Machine A makes 60% of the boxes. So that means B makes 40%. Huh? 60 and 40 is 100. 80% of the boxes made by machine A pass inspection, and 90% of the boxes made by machine B pass inspection. A box is selected at random. Find the probability that it passes inspection. So this is going to be pretty simple one. Probability that of A and that it passes inspection plus the probability of B and it passes or intersect. Okay, an intersection is just the product of the two probabilities. So this is very simple, very easy. Well, A is 60%, makes 60% of the boxes and 80% pass. So that would be 0.6 times 80%, 0.8, plus probability of B, it makes 40% of the boxes, 0.4, times a 90% pass rate, times 0.9, and you crank that out. This is a paper 2. That would be 0.84. Bazinga! B. The company would like the probability that the box passes inspection to be 0.87. Find the percentage of boxes that should be made by machine B to achieve this. Okay, so let's think of it this way. Let's say that the probability of B is equal to X, right? Well, then the probability of A must be equal to 1 minus X, because we only have the two probabilities and they must add up to 100%. Okay, and this is what we're saying is what percentage. We're trying to find the percentage of B and we're letting that represent X. Okay, so we need to set up the equation now. We need 0.87. And we want that equal to 0.8 times 1 minus X. Yeah. Okay, where did I get that? Well, 0.8, this is box A. 80% of the boxes made by machine A pass inspection. And the 1 minus X represents the percentage of boxes for A. Plus 0.9, that's the percentage that pass for box B, times X, that the percentage that we want box B to make. Okay, and so if we crank that, yes, then 0.87 equals 0.8 minus 0.8x plus 0.9x. So this would be what point? So 0.07 equals 0.1x, and we're going to get x equal to 0.7, which is 70% of the boxes. So that wasn't as difficult as you might think. Next up, we had all these integration problems, and I just put a bunch of integration using U substitution. Please, please, please work on all of your integration. Some of these we did in class, but let's go ahead and do this. So we'll say this is F1, CE, F1, I'm sorry, F2, F3, this is C1, C2. So we know what we're working with. All right, so f1 would be the integral of x squared over 3x cubed minus 1 to the 4th power dx. Okay, I'm going to let you, I look at that, there's no way I can integrate that without u substitution. I have no method. And I'm going to let u equal 3x cubed minus 1. And the reason I'm doing that is I know that when I take the derivative, I'm going to have an x squared, which is what I'm going to need to replace. So du equals 9x squared dx. So now we're in business. So we need this to be equal to, and the first thing I'm going to do is my u substitution. That's a crooked line. U to the 4th, right? Replacing 3x cubed minus 1 with u. Integral. And let's see. I'm going to put in du here and 1 over du. But right now they are not equal because I've taken care of x squared and dx with the du, boom, boom, but I need to compensate for this big giant 9. So to compensate and make it equal, to make this coefficient 1, I need to multiply this by the reciprocal of 9, which is 1/9. So then this would be 1/9 the integral of u to the negative 5 du, which equals 1/9 u to the negative 4 over negative 4 plus c, which is equal to negative 4/9. Well, let's clean this up. Let me do that differently. What did I do negative 4/9? Sorry. So that would be negative from here 1 over 36 u to the 4th plus c. And using my substitution, substituting back in for u, I get negative 1 over 36 multiplied by 3x cubed minus 1 to the 4th power plus c. Done. All right, let's do C1. I'll move that up here. C1. Integral root sine x cosine x dx. I have to let u either equal sine x or cosine x. That's clear. And I'm going to do sine x because the derivative is cosine x. Very simple. U equals sine x. Du equals cos x dx. So that means this is equal to the integral of root u du. And since du, when I do root u, I've taken care of the sine x, and the du takes care of cosine x and the dx. So this is equal to the integral of u to the 1/2 du, which equals 1/2 plus 1 is 3/2. So that's u to the 3/2 over 3/2 plus c. And that becomes 2/3 u to the 3/2 plus c, which equals 2/3. Careful here, you need parentheses like this, replacing u with sine x. Sine x, it's all to the 3/2. Now you could drop the parens and put the 3/2 in there if you wanted, plus c. And please understand, I'm going to go over here, that this is equivalent to 2/3 times the square root of sine x cubed either here or in here. It doesn't matter. Same thing, plus c. Okay, so let's continue. This is going to be a long one with all these integrals, so you can fast forward if you need to. And let's see. Nope. I got to get rid of all the scribbles. Bam. All right. So now we're going to do E. Okay. So let's see. Whenever you have E you are going to let the u be whatever is in the exponent. It's just that's the only way you're going to be able to integrate it. U equals x minus x squared, so du is equal to 1 minus 2x dx. So let's get into the substitution. So then that would equal the integral of, I'll take care of 2x minus 1 minus in a second, e to the u du. Okay, so what have I taken care of? With e to the u, I have taken care of x minus x squared. Du is 1 minus 2x, and I have 2x minus 1. Well, 1 minus 2x is the opposite of 2x minus 1. Opposite is the negation. So all I have to do to make this truly equal is negate the integral, because negative 1 minus 2x becomes negative 1, ka-ching, positive 2x, ka-ching. Done, 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 done. And then the integral of e to the u is e to the u plus c. And then we do our replacement, our substitution, e to the x minus x squared plus c. Couldn't be simpler. Okay, let's do this f. So I'm going to let u equal x cubed minus 3x du equals 3x squared minus 3 dx, yo-yo, equals 3 times x squared minus 1 dx. Okay, so we got a lot of compensating to do here. So I'm going to say equals the integral, do my u substitution first, so that's going to be down low like J-Lo, 1 over u du. They are not equal yet. I haven't taken care of anything. Let's look at x squared minus 1, and I have 1 minus x squared. The negative makes this x squared negative, ka-ching, taken care of. Ooh, I already ka-chinged this one, ka-ching. And the negative 1 takes care of the positive 1. Bam! And we already took care of the dx with the du, okay? Our only other issue is this is 3 times as much, so to compensate that and make that coefficient a 1, I'll multiply by the reciprocal of 3, which is 1/3. I'm in business. So this is negative 1/3. The integral of 1 over u is the natural log, absolute value of u, plus c. Clean that up, negative 1/3. Natural log, absolute value of x cubed minus 3x plus c. Done like a bun. The third F. Okay. Tricky, tricky, tricky. Now, this is if I let u equal x, then the derivative of x is 1. That's not going to get rid of the natural log of x. So I'm going to have to let u equal the natural log of x. And this is going to work out like pancakes and syrup beautifully, yes? Delectable. Du equals 1 over x dx. So I'm now going, I got to write the integral of this, so dx. This is going to equal the integral, let's do my u first, of u cubed. So ln x is taken care of. Du equals 1 over x dx. Dx taken care of. There's really a 1 over here, 1 over x. Bazinga. Could that be any easier? This becomes u to the 4th over 4 plus c. Doing my substitution, u is equal to the natural log of x, so that becomes the natural log of x to the 4th. Oops, I didn't leave any room for the fraction. Over a little tiny 4 plus c. Done. Last integral. I'm getting tired of talking. I need a water break. Holy smokes, 14 minutes. But you can fast forward through this puppy if you need to. All right. If I let u be equal to x, then I get 1, and that doesn't help me here. So my u is going to have to be 1 minus x squared du equals negative 2x dx. So This equals the integral. I'm going to take care of my u first, so that's going to be u to the 5th power. Ka-ching, this guy's taken care of. du. Well, du equals negative dx, and this is not negative, so I compensate for that. And the coefficient of this x is a 1, so to compensate for that, I multiply by 1/2, the reciprocal of 2. Let me get that negative out there. And so, ka-ching, I've taken care of that. Oops, dx, taken care of that. So this is 1 over u to the 5th, so this equals negative 1/2 times the integral of u to the negative 5, which is equal to negative 1/2 u to the negative 4 over negative 4 plus c equals negative times a negative is a positive. So that's going to be 1 over 8 u to the 4th plus c, which equals 1 over 8. What did I let u equal? 1 minus x squared. 1 minus x squared to the 4th power plus c. Done with the integration. All right, let us go to the last one of exam Jan 7, which is number 1. A standard die is rolled 36 times. The results are shown in the following table. So we have a score of 1 through 6, and our frequency is, my frequencies are 3, 5, 4, 6, 10, and 8. Okay. Write down standard deviation. Calculator. Write down the median. Calculator. Find the interquartile range. Calculator. This is an easy problem. I'm going to go. I need a spreadsheet. Okay. And so my categories were score and frequency. Okay, so now I'm going to enter my scores. They were 1, 2, 3, 4, 5, 6. Okay, and then my corresponding frequencies were 3, 5, 4, 6, 10, and 8. Double check your data. 8, 10, 6, 4, 5, 3, 1, 2, 3, 4, 5, 6. Okay, couldn't be any easier. Now, when you have a frequency, a lot of times we just have one set of data. We just have the data. But now we have the score and the frequency. Okay, so that's, you have to remember to do something here. Menu, stats, stat calculations. Accidentally did linear regression. I don't want that. Menu, stats, stat calculations. One variable stats. We are always going to use one variable stats. Okay, we only have one list. You might think, hey, there's 2 things, but it's about one thing. It's about the scores and their frequency. The one thing is the scores. That's all. So number of lists 1. It's always going to be 1. Okay. X1 list is the score. Okay. Now, if you don't have a frequency, you're done. You just have to check your result column to make sure it's not going to go over your data. But we do have a frequency list, and I titled it frequency. Bam. Okay? And you're done. You are done, 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 done. Let me move this over so I can see. I needed the standard deviation. You always use the sigma. Use the sigma. So my standard deviation is 1.61. So I am going to write that down. 1.61. Write down. Write down the median score. Oh, I got to find the median. Where is the median? Scroll down. Median is 4.5. 4.5. This might as well be wrapped up as a gift. Here, candidate. Here's 6 points. Thank you very much. Interquartile range is equal to Q3 minus Q1. If only there was a way to find Q3, 5, and Q1. Oh, the humanity of the situation. 5 and 3, so that's going to be 5 minus 3, which is equal to 2. So, boys and girls, we have finished. It's a marathon, longest vid ever. 20 minutes. Let's go out with some more neon lights. We are back and better than ever. I've done all the damage I can do here, and I am out!